In this video, we're going to learn about transmission parameters. They're also called ABCD parameters. Okay, transmission or ABCD parameters. So we have four variables: V1, I1, V2, I2. So here is a network or circuit. We don't know what is there in this black box, but all we know that's V1, I1, and V2, I2. Remember, I2 is also entering into the circuit. Okay, so we have four variables and we can choose two of them independent and two of them dependent. So we can come up with, so by using those four variables, we can come up with new parameters called ABCD parameters. So V1 equal to AV2 minus BI2 and I1 equal to CV2 minus DI2. Do not represent or do not use small ABCD parameters or small ABCD here. The small ABCD has a different parameter or different equations. So the small ABCD parameters or equations are V2 equal to AV1 minus BI1 and I2 equal to CV1 minus DI1. Okay, so these are all different parameters. So they use small letters here. Big ABCD parameters are transmission parameters. These parameters are useful to find transmission voltage gain or impedance or admittance, something like that. Okay, so here, so forget about the small ABCD. I'm not going to use them or ask them in our class. So I'm going to talk about big ABCD parameters. So these two equations are important. V1 equal to AV2 minus BI2, I1 equal to CV2 minus DI2. A equal to called open circuit voltage ratio. Voltage ratio is V1 over V2 where I2 equal to 0. Whenever you see either I1 or I2 equal to 0, that's open circuit. Same thing, C equal to open circuit transfer admittance. So I over V is always admittance and it's open circuit because I2 equal to 0. And B is negative short circuit transfer impedance. Impedance is V over I where V2 equal to 0. You can see whenever voltage is 0, that's a short circuit. D is also negative short circuit current ratio minus I1 over I2 where V2 equal to 0. So in this case, A and D, they don't have any dimension or any units. So those are unitless. And B and C, B is measured in ohm because it's V over I, it's impedance, and C is measured in Simon, that's admittance, I over V. Now we're going to solve an example to find ABCD parameters. So here is an example. In this example, he's asking us to find ABCD parameters. By the way, for the ABCD parameters, there is no equivalent circuit. For H parameters, Z parameters, Y parameters, we have equivalent circuit, but not for ABCD parameters. Now, okay, we always take I1 and I2 both are entering into the circuit. Now to find A equal to, you can clearly see here, which is V1 over V2, where I2 equal to 0. And we can find the same circuit. We can use the same circuit to find C, which is I1 over V2 when I2 equal to 0. Okay, so here is a circuit. Now I need to find A. I need a relation between V1 and V2. Okay, so here I know there is no element here, so I can say V2 is right here. So all I need relation between V1 and V2. So I1 is going to come, I1 is going to split Ix and Iy. Same Iy is going to go here because I2 equal to 0, right? So can I say 3 and 5 ohms, they are in 3 and 5 ohms, they are in series. So if I redraw a circuit, it's going to be look like this. 2 ohm. I'm going to separate them just for simplification purpose. So this is 3 ohm. I don't have this branch anymore. And this is 5 ohm. Okay. Now here is our V2. And can I say the voltage here is, this is V1. So I'm going to use the voltage division rule. So by using voltage division rule, V2 equal to total voltage times same resistance divided by total resistance. So if elements are in series, we can use the voltage division rule. So by using voltage division rule, V2 equal to V1 times 5 over 3 plus 5. It's not 3 plus 8, it's 3 plus 5. So V2 over V1 equal to 5 over 8. If I take it, reverse it, V1 over V2 equal to 8 over 5, and there are no units for that. Now to find C, next parameter C, okay, we're going to use the same circuit. I need relation between I1 and V2. So if you look at here, here is I1, and I already mentioned in the above circuit, this is Ix and Iy. Can I say V2 equal to 5 times Iy? Okay, V2 is 5 times Iy. Now I'm going to convert that Iy, or I'm going to indicate Iy in terms of I1. I'm going to use the current division rule. So Iy equal to total current I1 times opposite resistance, which is 2 over total resistance, 2 plus 8. Okay, so Iy equal to 2 over 10 or 1 over 5. So V2 equal to, so this is I1 over 5, V2 equal to 5 times I1 over 5. These two get cancelled, V2 equal to I1. So C equal to I1 over V2, that equal to 1. The units are same. So we found first two parameters. Now we're going to find B and D. So for B, it is short circuit, negative short circuit transfer impedance. So we're going to short circuit this. So I'm going to redraw the circuit. So when I redraw the circuit, so to find B and C, V2 is 0. So V2 is 0, voltage is 0, that means short circuit. Now can you see this 5 ohms and 0 ohms are in parallel. So since these two are in parallel, 5 parallel with 0, no current is going to pass through this. All the current is going to go over here. By the way, this is our I2. Okay, so we can ignore that 5 ohm resistor. Okay, so this is our circuit. This is I2. The resistance here is 3 ohm, 2 ohm. Okay, and here is our I1 and V1. Now B equal to, what is B value? B equal to minus V1 over I2, minus V1 over I2, and D equal to minus I1 over I2. I mean, both cases V2 equal to 0, V2 equal to 0. So we made V2 equal to 0, and this is the equivalent circuit. Now to find D, always it's easy to find D first. So all I need relation between I1 and I2. So can I say, by using the circuit, I1 is going to come, it's going to split Ix and Iy. So can I say Iy equal to total current times opposite resistance divided by total resistance. Okay, so Iy equal to 2 over 5 I1. Can I say Iy is nothing but negative I2? Iy equal to negative I2. So I can say negative I2 equal to 2 over 5 I1. Okay, so D is nothing but negative I1 over I2. So if I substitute this, negative I1 over I2 equal to, isn't it 5 over 2? Okay, I will end up with, if I bring it to the other side, we will end up with 5 by 2. This is our D. D value is 5 by 2. Now coming back to B, now I need relation between V1 and I2. Okay, V1 and I2. Now I know the voltage here is, this is V1. Can I say V1 equal to 2Ix? Okay, but I need in terms of I2, not Ix. So I'm going to convert this Ix into I1. So I'm going to say Ix in terms of I1. I'm going to use the current division rule to find Ix. Ix equal to total current I1 multiplied by opposite resistance, which is 3 over 2, 5. 2 plus 3, 5. So I'm going to replace this with I1, which is 2 times 3 by 5 times I1, which is 6 over 5 I1. V1 equal to 6 over 5 I1. Now I need relation between I1 and, I need to convert this I1 in terms of I2. From D, I already know. Can I say I1 equal to minus 5 by 2 I2 from this? So I'm going to substitute it here. V1 equal to 6 by 5 times minus 5 by 2 I2. Okay, 5 get cancelled, so V1 equal to minus 3 I2. Okay. Now B is nothing but minus V1 over I2. So if I take the I to the other side and negative to the other side, we will end up with 3. Okay, so this is V over I, so 3 ohm. That's a B. So now I have all 4 quantities. I have ABCD parameters. The transmission parameters are A, B, C, D. I have B equal to 3 ohm, D is 5 by 2, C equal to 1. Okay, C equal to 1 and A equal to 5 by 8. A equal to 8 by 5. A equal to 8 by 5. Okay, these are the ABCD parameters. Thank you.